Okay, the next tutorial is over scientific notation. Now, the purpose of scientific notation is to be able to write a number that has a lot of zeros in it, either because it's really, really big or because it's really, really small, quickly, and in such a way that it's not confusing. The way this is done is by expressing the numbers in powers of 10. So the standard form for scientific notation is m times 10 to the n, okay, where m is a number that is between 1 and 10. And really, this is not 10. It's right up to 10. So like 9.99999, so on and so forth. Okay? So scientific notation, you would never have a number in scientific notation that looked like this. That is completely wrong, because this m value is not between 1 and 9.99999. So this whole, that's wrong. Okay? N is the exponent, and it's equal to the number of times that the decimal point was moved. N is positive when the original number is greater than 1. Okay, so n is positive if m is greater than 1, and n is negative if m is less than 1. Okay, and that m, I'm talking about the original number. So let's look at an example. Let's write this number in scientific notation. Okay, so first step, find the decimal, and then you're going to move the decimal so that it's behind the first non-zero digit. Okay, so here's the decimal, and it has to be moved behind the first non-zero digit. Okay, so that transforms the number into 5.2346876. And after we've moved the decimal place, we'll put times 10, because we've changed it into scientific notation. And now n is the number of times that we moved the decimal point. So count how many times that we moved it, and we get 4. So our exponent is going to be 4. Now we have to decide if that 4 is going to be a positive or a negative 4. So we'll look at that original number again. I'll put it over here so it's kind of cleaned up a little bit. So we put it over here, and is this original number greater than 1, or is it less than 1? Okay, so obviously this is greater than 1, which means we're going to have a positive exponent. Okay, so our final answer here for this number being in scientific notation would be this. Okay, now we can have a really, really small number also. We could do something like this. And we might want to change that into scientific notation. So again, you're going to find the decimal point, okay, and you are going to move it so that it is behind the first non-zero digit. So there's our decimal point, and now we're going to move it so that it's behind the first non-zero digit. So now we rewrite the number 5.2346876. Okay, up until this point it looks exactly like the previous example, and we're going to put our times 10, and now we have to figure out what our exponent is going to be by figuring out how many times we moved the decimal. Okay, so it looks like we've moved the decimal 7 times, so we know the exponent is going to be 7, but we don't know if it's positive or negative yet. Is the original number larger than 1 or less than 1? Good. This one is less than 1, so this is going to be times 10 to the negative 7. Alright, so that gives us our final answer there for that one. And that's really all there is to scientific notation. Now, the purpose of scientific notation that we're really going to take advantage of is being able to write specific numbers with a specific amount of significant digits. Okay, so for example, this 100 here, how many sig figs does it have? Okay, so there's no decimal, so we're going to start on the right hand side and find the first non-zero digit. So this has 1 sig fig. Okay, what about this version of 100? Okay, this one does have a decimal, so we're going to start on the left hand side and find the first non-zero digit and count everything after it. So this one has 4 sig figs. Or you could even do one like this and just put a decimal point there and again find the sig figs. This one has 3 sig figs. But what if a problem that we worked required that the answer only have 2 significant digits? What if we had a given that started with 2 sig figs and therefore our answer had to have 2 sig figs and the answer happened to be 100? How can we write 100 with only 2 significant digits? You've seen 3 examples up here at the top and none of them are 2 sig figs. There is no way to write the number 100 with 2 sig figs unless you change it into scientific notation. So, you would take 100, okay, and if there's not a decimal, then you know that the decimal is always at the far right of the number, okay? And you are going to move that decimal behind the first non-zero digit and rewrite it. Okay, so 1.00 times 10, and then how many times did we move it? 2. Is the number 100 larger than 1 or less than 1? Obviously it's larger, so that's a positive 2. Now this has 3 sig figs. We only want 2 sig figs, so our final answer then becomes 1.0 times 10 to the second. That is the number 100 with just 2 significant digits. Okay, let's check that out, make sure that you understand. That times 10 to the second, we can undo that. We can go 1, 2, and fill in that little well with another 0. When we do that, we change it back into standard form, and we get 100. You drop the times 10 part off. So this does equal 100. Those are equal to each other. Okay, so this provides us, scientific notation provides us with a way to get the appropriate number of significant digits when a problem requires that. So if there's no other way to write it, change it into scientific notation. You need to be able to go back and forth between scientific notation and standard notation. Okay, the next thing to consider is when you have 2 numbers that are in scientific notation and they need to be multiplied. Now, we obviously have calculators that can do this for us extremely quickly. However, we as humans, we are prone to error. So it is highly likely that at some point you're going to be clicking on the calculator buttons and you're going to hit a stray button. And then you won't know that you did that. You'll keep going. You hit the enter button, and whatever pops up on that screen you have been trained to believe is true. Okay? And you'll write that down blindly, thinking you got the answer right the whole time because that's what the calculator told you, when in fact you are completely wrong. So you need to be able to understand or to tell when the calculator is giving you garbage before it happens. Alright? So here's how you do that. In order to multiply two numbers that are in scientific notation, you're going to multiply the m part of the number, and then you are going to add the scientific notation part, the exponents, get added together. Okay? And this is just regular old algebra. You've done it before. When two numbers are on the same base, then you can add their exponents. So for example, let's say that we had 5.6 times 10 to the 12th, okay, and we can multiply that by 7.102 times 10 to the 4th. Okay, so let's figure out what that's going to be. The first thing that you're going to do is multiply the 5.6 by the 7.102. Okay, and when you do that, you're going to get 39.7712. Okay, so that's the multiplication part. Then you're going to put your times 10. The next step is to add their exponents together. So that gives us 16. Okay, now I told you previously that you cannot have an m that is not between 1 and 10, or 1 and 9.999, because then you're not on a base 10 scale anymore. So what we have to do is take that decimal and move it back one more spot, and that's going to increase the exponent over here by one more. So we get 3.97712 times 10 to the 17th. Now if you check that in your calculator by using your times 10 function, then you will see that that is the correct answer. And so you would have some idea of that before you ever typed it in. The easiest thing to do, I think, is to check the exponents part first. You know that whatever your answer is going to have to be times 10 to the 16, and then you could either go one less or one more for this circumstance down here, either in case the number happens to be larger than, or it's larger than the 1 to 10 range, or maybe it's smaller than the 1 to 10 range. Your exponent could drop by 1, or it could raise by 1. In this case, it raised from 16 to 17. If this number over here had been less than 1, then this number here, the 16, would have dropped to a 15 instead. So anything that your calculator tells you from times 10 to the 15, times 10 to the 16, or times 10 to the 17, you would accept as a possible outcome. That would be reasonable. But if the calculator gave us like times 10 to the 24th, that's not reasonable. Okay, and you should recognize that that's garbage. You hit something wrong on the calculator and you need to try it again. Okay, now let's look at division. When you are dividing two numbers that are represented in scientific notation, you're going to do the same thing. You're going to divide the m part of the scientific notation, and then instead of adding the exponents, you'll subtract them. So let's see what happens if I use the same example from the problem above, except I divide it. So I do the 5.6 times 10 to the 12th, and I divide that by 7.102 times 10 to the 4th. Okay, well, again, you're going to take the m piece of the number and you're going to divide it. And you should get 0.785103. Okay, and then we'll put the times 10 on there. And now we will subtract. The 12 minus 4 is 8. So this is our answer, except it's not between 1 and 10. The m part of our number over here is less than 1. So you're going to have to, again, grab the decimal and move it behind the first non-zero digit. So now our number becomes 7.885103 times 10 to the, and then since we had to move the number or the decimal point towards the right because the original number is smaller, then we have to subtract 1 away from our exponent. So this is going to become a 7. And if you type that into your calculator, you will see that that is, in fact, the correct answer. And as you get more and more comfortable with this, you will recognize up here at the top in the beginning that you are dividing a number. You are dividing a smaller number by a bigger number, so you're going to get a decimal point. Now, of course, I'm just talking about the m part of the number. Obviously, we know that something that's times 10 to the 12th is larger than something that's times 10 to the 4th. But the m piece of both of these numbers is what I'm referring to. So 5.6 is smaller than 7.102. So you should have recognized that our answer was going to be smaller than 1, which means whatever exponent we got, we were going to have to subtract away from it. Okay? And then the opposite is true for the above example. Okay, so let's see if you can apply our new knowledge. Let's say that we have the following numbers that need to be multiplied by each other. Okay, I want you to do this without a graphing calculator or without your scientific calculator. You can use a regular standard calculator if you need to in order to multiply your m parts and then add your exponents together. So take a couple of seconds to do that. If you need to, pause the video and then I'll put the answer on the screen here in just a second. Okay, and you should have come up with 4.152 times 10 to the 10. Okay. If you didn't get that right, then go back and review what we just watched and see where you missed. Try this next one. What if we have 5.0 times 10 to the 15th divided by 2.5 times 10 to the 7th? Okay? Try that one. I'll put the answer on the screen in just a second. Okay, we get 2 times 10 to the 8th. Now this one should have been really easy to do in your head. Alright? 5 divided by 2.5 is 2, because 2.5 is exactly 1/2 of 5. And then 15 minus 7 gives us 8. So 2 times 10 to the 8th, and that one should have been really easy. Okay, so I think that we will leave it here for scientific notation. Thank you for learning with me today, and I will see you next time.